How to make good decisions. If you take a book on rational decision-making or hire a consulting firm, you probably will get the following message. Look before you leap. Analyze before you act. List all the alternatives, all the consequences. Estimate all the utilities and the probabilities. Multiply them, do the calculation. And go with the highest expected value. Now, this is a beautiful mathematical scheme, but it doesn't describe how most people make decisions, and not even how those make the decisions who write these books, as the following story illustrates. A professor from Columbia University in New York had an offer from a rival university, and he could not make up his mind whether to leave, stay, accept, reject. A colleague took him aside and said, "What's your problem? Just maximize your expected utility. You always tell your students to do so." Exasperated, the professor said, "Come on, this is serious." What I would like to do today with you is to introduce you into our research on heuristic decision-making. What is a heuristic? Nassim already gave a short introduction. A heuristic is a rule of thumb, and that you use in order to make better decision-making, better decisions, not just fast decision-making. So, the first thing I want you to understand is there a basic difference between risk and uncertainty. So, a decision under risk is one where you know all the alternatives, all the consequences, all the probabilities for certain. This is where most economic theories are about, most theories in finance, and most in behavioral economics. Very few situations where we make decisions are about risk. For instance, people have said that banks play in a casino. If they only would play in a casino, then we could calculate the risks. They don't. They act in a world of uncertainty. And most relevant problems are outside. But very few study that. And uncertainty means decisions where you do not know all alternatives, all consequences, and the future is uncertain. And that's what I will talk about. And one key message will be that what is best according to standard ideas about making decisions is not the best in an uncertain world. And I will talk about less is more, about how to make better decisions with less information, not just faster and with less effort. And I hope that some of you will leave here sleepless, particularly those who have gotten an MBA or some other university training. Okay, this is what I will talk about. First, about uncertainty. The best decision under risk is not the best decision under uncertainty. This is about the limits of optimization. We already had heard about that. Second, about heuristics. It's often said that heuristics, they save you time, yeah? But then you pay for it because you do not as well. That's the typical message you read in almost every book of social psychology, behavioral economics, and elsewhere. This is not true. I will show you that in an uncertain world, you can make actually better decisions with simple heuristics than with complex models. And I will explain you why. The story of that if you do something more simpler, you will lose a little bit accuracy is true in a world of risk where you know everything. If you're God, then you don't need heuristics. But if you're mortals like us, you will. Third, about simplicity. We'll talk about the value of simplicity. The general idea is complex problems do not always require complex solutions, even if we usually act this way. And finally, less is more. More information, more computation, more time is not always better. You often just need a minimum of information and then act. Okay, are you ready? So, I'll give you now two examples about heuristic decision-making. Let's start with sports. Is there anyone here who plays baseball? Hands up. Nobody. Cricket? Nobody. Soccer? 3. What are you doing all the time? Okay, assume you play one of these sports. A ball comes in high, and an experienced player knows immediately where to run. How does he know? If you ask him, what do you get? Have you ever interviewed a soccer player? Intuitive. Yes, it's intuition, because the person knows where to run, but he cannot explain it. So, how does a player know? The typical theory is it's a complex problem. Something complex is going on in the mind. And here is a quote from Richard Dawkins in his famous book, The Selfish Gene, where he exactly proposes this idea. And he says, when a man throws a ball and so on, he behaves as he had solved a set of differential equations in calculating the trajectory. Have you ever calculated the trajectory of a ball? Good luck. So, and then at some subconscious level, something is going on equivalent. And you note in the second line, he puts in the as if. That's the economic as if. That's, we make a theory, he knows that it cannot be, but he has no better idea, so you do as if. And you don't try to find out how it's working. What I show you now is that a number of experiments show that what experienced players do has nothing to do with this story. They use a simple heuristic. I'll show you the simplest one. It works when the ball is already high up in the air. It has 3 parts. First, fixate your eye on the ball. Second, start running. And third, adjust the running speed so that the angle of gaze remains constant. This player is doing exactly that. Keeps the angle constant and arrives there where the ball is coming down. Do you want to see it again? The important thing is the player is looking only on one thing, the angle of gaze, and ignores every variable that's relevant for calculating the trajectory. The initial distance, the initial velocity, the initial angle, the speed of the wind, and this whatever is there. So here we have an example of a heuristic. Where do these heuristics come from? Now, this one, you can find them in bats, in all kinds of animals, in fishes, and they just run to keep the optical angle constant. So, you got just an illustration that things can be totally different. It's also important in business. You need to fixate, find out the one single important thing, and the rest will come. A heuristic can be used unconsciously, as with players, they don't know what they do, but also consciously. When you understand it, you can train people. Now, this story is very different from the story you read in psychology textbooks, where heuristics are somehow in an unconscious system one. Don't believe these stories, even if they're told by Nobel laureates. So, here's an example about using the same heuristic deliberately. Remember the miracle on the Hudson River? So this plane took off LaGuardia, and a flock of Canadian goose came in, which are too heavy for this plane. And both machines stopped. They turned around and then had to make a decision. Will we get back to LaGuardia, or do we have to do something different? Going to the border. How do you do the decision? Do you calculate? No. The pilots are trained to use the same heuristic. So, how does it work? If you fixate the tower, and if in your windshield the tower slowly goes up, you will not make it. That's what the co-pilot actually says. Okay. That's the first illustration of a heuristic. The key point is, to solve problems in the real world, you should not attend to every piece of information. You need to ask a question, is there one variable? Is there a simple heuristic that can solve it? And if you find it, then you can do better than your competitors. There's no robot or a computer who can catch balls by calculating trajectories in real time. Second example, investment. Okay, assume you want to invest your money in a number of options, but you don't want to put everything in one pot, but you want to diversify. But how? The story I'm telling you is about the failures of modern economic theory. this theory is based on a world of risk, and it fails, or can fail in the world of uncertainty. We need different theories. Nassim is building on some of those. What I show you now is a standard theory, Harry Markowitz Nobel Prize winning mean variance model. So, which gives the answer to your questions. How to invest money into N options. I'm not going mathematics. The basic idea is you maximize the mean, the gain, and you minimize the variance, the risk. So you're done. Or, when Harry Markowitz did his own investments for his retirement, he used his Nobel Prize winning theory. We might think, no, he did not. He used a simple heuristic that we call 1/n. Divide your assets equally. You don't have to do any calculation. So if you have two options, 50-50, a third and so on. Now, the important question is not now to say, oh, that's stupid. He could do better applying his theory. But we know since long that many of those who teach the traditional theory for risk don't apply the theory to their own life. Just ask an economist how he chooses his wife, whether he's done the calculation and listed all the alternatives and all the consequences. Okay. Now, one can actually study now how good the theories are. And how do you do this? For instance, you take 10 years of stock data so that the mean variance model can estimate its parameter and test next month. Then you move this window for a month and test the next one until you run out of data. What was the result? In one of the studies I show you, 1/n made, according to many financial criteria like Sharpe ratios, more money than the mean variance optimizing model. Yeah. And the real question is now different, because you should have no surprise now, because you know you're in a world of uncertainty, the real world. And we don't know whether optimizing models work at all. The question is, in what world does it work? And here are three features of world, here financial worlds, that help us to decide whether we should use a simple intuition or the maximizing calculation. If predictive uncertainty is large, which is the case with stocks and funds, then 1/n is, and I call this ecological rational, in this world rational, better than mean variance. The same if the number of options is large and if the learning sample is small. Small is 10 years. Now you can do a computer simulation. So if you have 50 alternatives, how many years of stock data would you need so that the complicated mean variance computation actually get better than 1/n? What do you think? 10 years is too little. 11 years? 20? The best estimate is 500 years. So in the year 2500, you won't be around anymore, but the children of our children and so on, they can now switch to the Nobel Prize winning model, provided that the same stocks are still around in the stock market in the first place. Do our banks understand these connections? I'm not sure. I'll show you a letter I got from an internet bank where I'm a customer. And it says, it's in German, I translate, with Nobel Prize winning strategy to success in investment. And then the letter says, do you know Harry Markowitz? No, you should know him, and the story is told that he won the Nobel Prize. And the bank uses now his method, and a warning is from your intuitions. And you see, what this bank has not understood is that I sent the letter 500 years too early. So this is the research we are doing. We are trying to provide an alternative to the reigning fixation on worlds where you know everything. So the study of rational decision-making in an uncertain world. That's the science of heuristic. There's three questions. What's in the adaptive toolbox of people? And you just saw two heuristics. The gaze heuristic or just invest equally. This is not a heuristic for money. If you have 2 or more children, you may also use the same thing to divide up your love, your time. The second question is a normative, and that's new. In what environment is a heuristic superior to a more complex model? This is a new question because according to practically every textbook you read, a heuristic can never be more accurate, but they can, you just saw. And finally, intuitive design, how to build systems to help experts to make better decisions. And that's the last example I'll show you. We call this intuitive design because we are not using methods that nobody can understand. When I was sitting here in the first row and listening to one of the talks, my neighbor, who should remain unidentified, thought, I don't understand a word. Now, that's exactly the point. We study how humans make and humans think and build models or heuristics they can actually use. So, here's the problems from medicine. A man is rushed into a hospital with severe chest pains. The doctors need to make a decision whether to send him in the intensive care unit or in the regular bed with telemetry. That can be a decision about life and death. If the person gets a heart attack, should be in the ICU, in the intensive care unit. If not, he should be in the regular bed because the ICU is one of the most dangerous places where you can be. A friend of mine died there from a virus he just picked up. Yeah? So how do doctors make this decision? In a hospital in Michigan, which we worked, most doctors send 90% of all patients into the coronary care unit. That's called defensive decision-making. The doctors protect themselves because if someone dies from a heart attack in a regular bed, they may be sued. So rather, if the person dies from a virus in the ICU, that's okay. You're not sued. But the problem was costs up, quality down. So what do you do? And the first intuition was the usual one, complex problem, complex solution. So they asked for researchers from the University of Michigan, and they proposed them to do a so-called heart disease predictive instrument that consists of this table you see here. You don't have to understand it, you just should look at this and understand that doctors don't like it because they also don't understand it. And a pocket calculator, and then if you're the patients, you push in the relevant probabilities, and then you push enter, and if the number that you see is above a threshold, ICU. Okay? Otherwise not. That's it. The problem is only the doctors don't like it, and when the researchers left, then it went back into the waste paper basket. So then the researchers learned about our research about heuristic. That's an uncertain world here. And they designed a fast and frugal tree. That's a specific kind of heuristic for treatment decision. And this is designed in an intuitive way so that everyone can understand it who doesn't know what a logistic regression is. This was the other model. So it just asks 3 questions. It goes sequentially, as people think. Is there an anomaly in the ST segment, in the electrocardiogram? If yes, immediate decision. If that's not the case, the second question is asked whether the primary complaints are chest pains. If not, regular bed. Otherwise, a third question is asked, is any one of these factors there, and the decision is done. Note all 50 probabilities are gone. This is a heuristic. Now, how good is it? Now, first, it's quick. You can do it much faster. It's frugal. You don't need to spend all this thing. And it's transparent. The doctors understand this, as opposed to the complex system. But how good it is? And I'll show you the study. What you need to know here is that you want to have the proportion correctly assigned patients, so those who actually get a heart attack, high. Those who are incorrectly sent into the ICU, low, okay? And something up here, but that's too difficult, this problem. This is the chance level. You said everyone or nobody in it, and you don't want to be on that side. This is worse than chance. So where do you think the doctors are who do defensive decision-making? Okay, they're slightly less than chance, but patients usually don't ask questions or don't check. But they send 90% of those who should be in and so in here. Where is the complex logistic regression system with 50 probabilities? Now you see many points because you can adjust the level. It's on the right side. It's a little bit weak up because you want also to be up here. in order to not miss this. And where is this simple heuristic? It's better than the complex system, of course, and better than the patience. So, we have a case, another case, where in an uncertain world you can do better in predicting heart attacks with less information. This system has all the information that the fast and frugal tree has. And that's why it's better. It's robust. Okay, that is a study. Oh, now we'll soon hear something. You just see that the same thing applies to, this is our 20 different studies. In case you fit data, always you do better with the optimization model, as opposed to a model that we just had, one good reason, or tallying. But if you predict the world in the uncertainty, then already you have the crossover. Less is more. And that's very important. So this is, yes, my final slide. I was talking about uncertainty. The best decisions that the textbook teach are not the best ones in the real uncertain world. Many management theories teach you to look at everything. That's the worst thing you can do. Second, heuristics. Heuristics are not what you usually hear, something second best. But in an uncertain world, heuristics can do better than complex models, and they are not the result of a flawed system. Simplicity. Complex problems don't require complex solutions. And finally, less can be more. More information, more time, and more computation is not always better. And you can do best when you, finally, the art of heuristic decision-making is to fixate on the few important things and ignore the rest. Thank you for your attention.